Hey guys, welcome back to my channel again. So today we're gonna continue with the linked list from yesterday. We looked at reversing the linked list, and the logic was pretty simple, right? So given the linked list of A to B to C, we just changed the direction of the pointer iteratively. So A to B, we change it to B to A, and B to C, we change it to C to B, so it becomes CBA. So that was the whole logic behind reversing a linked list. Now we're going to see how to implement it, looking at real example. I don't know if you can see my screen, or if not, I'm going to share it now. Yeah, so the question is, given the head of a singly linked list and two integers left and right, where left is lesser than right, reverse the nodes of the list from position left to position right, and return the reverse list. So basically, given the left and right, so in this example one, you can see that position is 2, the left is 2 and right is 4. So within that range, you see if the left is smaller than right, we reverse the node of the list from position left to position right. Yeah, so that's why it's reversed here for the given range. And here, here it's already left is equal or lesser than right, so there's no change. Also, it's a list with size of 1, so there's not much difference to be made. But how are we gonna implement this? So basically, when you cannot modify the values in the nodes of the linked list, you'll need to modify the pointers. So the key is the pointers. We're going to reverse the pointers of the nodes between positions M and N in the linked list. So that's left and right. So to reverse this link between nodes, we're going to follow the steps that we went through yesterday. Um, we need to manipulate the next pointers, right? And um, so and also we need to initialize the previous pointer. We also have to initialize the current pointer, and we also need two additional pointer in this case. That would be tail, and I'm just writing this here for the visualization purpose. Connection node. So the tail node will eventually point to the M node, which is the right, and it's gonna become the tail of the reversed sublist, right? So in this case, from 2, 3, 4, it's gonna be 4. So this is the tail. And we're gonna also have a node named connection, where this will point to the node just before the M node, so just before, and will connect to the new head of the reverse sublist. So it's gonna connect to the new head. So it's just basically reversing the direction of the pointer and then changing the new head and the tail. And after we do that, we're gonna traverse to the mth node. So that will be moving the current pointer one step at a time until it reaches the mth node. And when it's doing this, the previous pointer will follow the current pointer. That makes sense, right? And after that, we reverse the sublist from M to N. So we set tail to the nth node, um, and nth node using a loop. And inside this loop, we're going to use the third pointer, which is called third, to keep track of the next node. So how many pointers we have now? 1, 2, 3, 4, 5. Tail connection, the current, previous, and then now also the the third. No, previous and current is node. What I meant is next node. So yeah, that's the logic behind it. We're gonna see how to implement it. Let's try to do it here. By the way, this is the medium difficulty level, so it's pretty difficult. I first didn't get it. I had to look at the solution, but I implemented it myself. So I recommend when you have to go to the solution, just look at it, but you don't copy the solution, you try to implement it yourself. That way you can learn a lot from it. Also, it's helpful for your memory because these questions will surely come out in interviews. This one for sure, because I saw a tag on it and it said Google asks this kind of question. So yeah, some questions that you can expect. But anyways, let's start. So if the first node is not head, we have to return none, right? So return none. And first of all, we start with, I decided it's better if I use the comment. We initialize pointers, so that will be previous equals none and current equals head. Until here, it's the same as usual pointer execution. And now we have to move the current node to the nth node, which is the until to position right. M is the right. So we use underscore because this I is not important. Range m minus 1 to go over all the nodes within the mth range. And here previous is equal to current, and current becomes, what does it become? The next node after the current, right? So that will be current dot next. Now we mark the start of the sublist to be reversed. So that will be connection equals previous, and tail is current. Like I said before, right? So we have to mark the start of sublist by using the connection and tail pointer or node. And now we do the actual process. So we reverse the sublist from M to N. So that will be for, we use underscore again because it's not important, range M plus 1. One thing I learned from my advanced programming class was this underscore, and it's pretty useful, one of the things. And then args and quarks. But anyways, we use the third pointer here. Third equals current dot next, and current dot next equals previous, and previous is equals to current. Yes, so we're correctly reversing it. Current dot next for previous dot current. Yeah, and after that current is third, because we saved this current dot next in the third variable, and now we're taking the variable again. And now we fix the final connection. We fix the final connection. So that would be if connection, then connection dot next equals previous, else head is the previous, right? Um, head connection dot next is previous, head equals previous, and after it's done, tail dot next equals current, and return it. Let's see if this works. M is not defined in line 17. Huh? We defined. Oh yeah, of course we were. Right equals M, left equals N. Let's try again. M equals right. We got the cycle. Ooh. Ooh. What did we do wrong? Let me pause the recording for a bit. All right, guys, with the help of ChatGPT, I kind of found out what I was doing wrong. So I was mixing up the pointers. So I said we have to move the 2 pointers until they reach the proper starting point, right? So this previous should be instead, no, previous is known, current is head. Yeah, this one is right. We're gonna delete M and N. We're just gonna change it. If not head, return none. So let's, instead of for, we use while loop. And that nth node, by moving the current node to the nth node, and that means we're moving the 2 pointers until we reach the proper starting point. So that means while left is more than one, previous equals to current, current equals to current dot next, and just delete connection here. Left and right is equal to left minus 1 and right minus 1, so that they make a proper starting point. Now we define the tail and connection. That will be connection equals current previous. By the way, this is the illustration of the answer. But yeah, like I said, like how I explained, that's the way to go for it. So you can just ignore that. What else? So so while right, so we iteratively reverse the nodes until the right becomes 0, right? So that would be while right third equals to current next equals previous equals current equals third. And yeah, connection. Let's see if this works now. Runtime error. Line 28. Third equals current on next. Third equals current on next. Current on next is previous equals current equals third. And then write -1 if connection dot next is previous, else head equals previous tilde next is current. Yeah, it works now. But guys, I don't feel like I understand this fully. And if I am to do this all over again, I don't think I can make it up. So tomorrow I'm going to briefly go over this again, the logic, and then we're quickly going to draft the code again and then do some other example, or maybe just move on to the next topic, which I don't know what it is, but we're definitely going to check. But anyways, thank you guys all for listening, and that was it for today, and see you guys tomorrow.